what we're going to go over now is what that mole is, all right? So you guys have now seen that a mole can be molar mass, right? Right? Maybe? Yes. Okay, cool. So it can be a molar mass, right? So 1 mole of something is its molar mass. Now what we're going to look at is what the other thing we can use mole for, okay? Do you guys remember when we celebrated Mole Day? Yeah. Who remembers the date? Does anybody remember what the date was?
November.
So glad it was such an important day to y'all. All right. It was October 23rd. Correct. Oh, who said that?
Riley said it.
Sorry, Riley. Sorry. Good job. All right. All right. So we're going to be using that little Avogadro's number from here on out, okay? And what it's going to relate to is anytime that you have a little chemistry word, okay? What I want you guys to write up on the top of your page first, though, is I would like you to first put that little, I don't care what words you use, but I'm going to put horse divided by horse equals 1. So that I don't forget that's what's happening to my units. I'm dividing it by itself, and it equals the number 1, so we don't care, and they disappear. That's how we cancel things out, okay? So I'm going to put that there. I'm also going to put up at the top that thing that I said. What is one thing that you guys have to always do? Down to the right. Good. I heard you that time. All right, so I'm going to write that up here. Because if you can do that, you will never mess up. Unless you just put the numbers in wrong because you're not thinking. All right? All right, so down to the right. Words always go down to the right. Okay? All right. So, what are a couple things that you guys could go to a lab area and go measure? What's one thing? Mass.
Volume.
Hold on. We're writing. All right, so you guys can measure mass, volume, which we measure in liters or milliliters. Can you measure density? No, you can calculate it. You can measure mass and volume and calculate it, but you can't measure density. Okay, so the only other thing that you can also do is you can count. Okay, you guys haven't really had to do that yet. Okay, but you can count things. And this is more looking at a balanced equation. I know, right? And the units that we're going to use for that is going to be the mole or moles. Okay? And just so you know, we really shorten it up for you. So whenever you start writing it next to your little numbers, you can write it that way. Because it really shortens it up a lot. I know, 2 letters, right? All right. Okay, so 1 mole is going to be 6.02 times 10 to the 23rd particles. Okay? And when we're saying particles, I want you to put off to the side, I call them funky chemistry words. Okay? Funky chemistry words, meaning anytime you see the word like atom, molecule, formula unit, particle, anything else, okay, you're going to use Avogadro's number. You have to. That's the only way you can do it, okay? All right, so I've already told you now like 3 times this is Avogadro's number. Please write it the correct way on your notes, but if you would like to remember it as avocado, that's up to you. On that poster back there, you can see somebody. That was the way she remembered it. She's like, avocados. All right, so I don't know. All right, so this is Avogadro's number. And like I said, you're going to be using this whenever you see a funky chemistry word, okay? Now, what is the... Okay, so what is the particle, like the simplest particle for an element? An atom, good. Okay, so for example, we could say calcium, we could say aluminum, all those good things. A molecular compound. Yeah, there we go. So something like CO2 or any of your diatomic 7. okay? An ionic compound. We call these formula units. So you guys saw those words when we were first learning how to balance equations. And then we kind of just never went back to them. Okay, now you're going to be using them again. Okay, so when we're talking about an ionic compound, remember that's stuff like sodium chloride or calcium chloride or any of those. Okay, and because this would be a pain to write in that little square, you get to call them FUs. Get it out of your system now.
FU.
Okay.
Get out of your system.
All right. To change from particles to moles. All right. So 5 and 6 are basically going to be describing the logic method. So if you're somebody who is memorizing the rules, that's what 5 and 6 are talking about. Okay. But I'm going to make sure that you guys write off to the side an example showing the words coming down to the right, because you'll see that it's no different than what you guys were just now doing. Okay. So let's go ahead and put particles of element X. Okay. And then we bring those words down to the right, right? So we would have particles of element X. And we're going to be converting to moles. So we put moles of X on top. Okay? When you have this relationship, a mole to a particle thing, you're talking about only 1 mole, and this is now going to be Avogadro's number. So that's the only thing that's changing. You had the 1 mole in molar mass in the last few problems, right? Now we're going to go 1 mole Avogadro's number, and it can go on top or bottom, whichever one it needs to go on, okay? So, overall, you are dividing by 6.02 times 10 to the 23rd, or Avogadro's number. And then when you're going from moles over to particles, remember, so moles would be up top, it would go down to the bottom, so then you'd have particles on top, right? So you're going to be multiplying now by that number. Like I said, those 2 statements are just for my people who are memorizing rules. If you just bring your words down to the right, you will never mess up, okay? All right, so let's look at a couple examples. All right, so number 7, it says, how many molecules of CO2 are there in 4.56 moles of CO2? All right, so I'm going to circle what they're giving me. I'm going to underline what they want. Okay, how many significant figures does this have? 3. So I need to make sure my answer will have 3. Okay. Molecules. That's a funky chemistry word. So we're going to be using Avogadro's number. Okay. So we're going to start with what they gave me, which was the 4.56 mole of CO2. Okay. I'm going to bring those words down to the right. So mole CO2. And I'm going to end with molecules on top. I'm going to put molic, just so I don't have to write the whole thing. Okay? So now that we see that little relationship, that's 1 mole. And what goes on top? Avogadro's number. Good. Okay. Awesome. So this is a multiplication. Okay? So go ahead and type that in. Bless you. When you have an answer, go ahead and shout it out, and we'll get a second on that. .745 stuff, right? So 12. Okay. Good. All right. So we want to go to 3 sig figs. So we're going to go 1, 2, 3. Check that guy. We're going to round up to 2.75 times 10 to the 24 molecules. Make sure you're not leaving your numbers without labels. Okay. And I am expecting units with this part. You have to put your labels because when you guys get over to stoichiometry, that's going to be your best friend, making sure you know who you're talking about because it's going to change halfway through your calculation. Okay? Stoichiometry. It's great stuff. You guys are going to love it. Okay, so let's look at the other example. So this is just reversing what we just did, kind of, okay? So this one is saying how many moles of water is 5.87 times 10 to the 22nd molecules making up, okay? So this is what they gave me. This is what they want, right? So I'm going to go ahead and start with what they gave me. So 5.87 times 10 to the 22nd. This is fun to write. Moleic H2O. There we go. Okay. Then we're going to swing our words down to the right. So now we're going to have this. Because molecule divided by molecule is what? 1. There you go. Good. All right. And then we're going to change into moles of water. Okay. All right, so we have that mole-molecule relationship again. So we're going to say 1 mole is 6.02 times 10 to the 23rd molecules. And just a reminder on how you should be typing these into your calculator. Remember that would be 6.02, and then you would push the little second button, and then the one that has the x to the -1, because it has a little EE on top of it. And then you would just type 23rd. And you would just continue on with your little calculation, okay? So go ahead and type that in. When you have an answer, shout it out, and we'll second it. And then I'm going to get you guys practicing for a couple minutes. Like that? Is that what you got? Okay. So we want 3 sig figs, so we're going to chop off that last 0 because these guys don't count already, right? So we don't want this guy. Okay, so we're going to have 0.0975 moles of H2O. If your calculator said 9.75, look all the way over at the end. It says 9.75 times 10 to the -2. So just make sure you include that and you won't be wrong. If you just left 9.75, you'd be wrong. Okay? But you can write it either way. I don't care. I'll understand it. So,
say for example, if there's like 7 zeros and it's like 975,
you're better off like,
you just write the,
yeah.
like that works too.
Yeah. I'd prefer it in scientific, to be honest. Okay.